Let's take a look at some recursive logistic models. So number 13, assume there's a certain population of fish in a pond whose growth is described by, so here's important, they're telling us what it's described by, the logistic equation. It is estimated that the carrying capacity, if they talk about the carrying capacity, you're dealing with a logistic equation. In this case, the carrying capacity is 1,700 fish. Absent constraints, the population would grow by 230%. That's fast. If the starting population is given by 600, then after one breeding season and 2 breeding seasons, what's the population? Okay, so first off, here we have the recursive definition for the logistic growth. And the K is the carrying capacity. So this K value is the carrying capacity, 1,700. We also have the initial value, P sub 0, 600. And then the 230%, if we divide that by 100, we get 2.3. That value is R. Okay, now to find P sub 1 with the formula, we replace all the n's with 1's. And it would give us a formula which says P sub 1 equals P sub 0 plus R, which is 2.3, times 1 minus P sub 0 over K, which is 1,700, times P sub 0. We know what P sub 0 is, so we can now work this out. 600 plus 2.3 times 1 minus 600 over 1,700 times 600. And now we can go to our calculator and carefully type this all in. 600 plus 2.3 parenthesis 1 minus 600 divided by 1,700 parenthesis times 600. And we have our first year. The population's up to 1,492.94. Now, since this is fish, I would approximate this. Maybe we say 1,493. On the other hand, to get the right answer for that's not right. For part 2, oh my goodness, we don't want to round this at all. So I'm going to write this whole thing down. So we have P sub 1 equals 1492.941176. Yuck. But that's okay. To find P sub 2, we can go back and replace n with 2. And our formula would say P sub 2 equals P sub 1, 2 minus 1 is 1, plus, again, R, 1 minus P sub 1 over K, which is 1,700, times P sub 1. And then we calculate this. And now typing that in 3 times is kind of painful. If you know how to store values in your calculator, you might want to store this value and then just hit recall 3 times. I have a store recall ability here. Or you have an answer button. You could use this as the answer button. Or you could type it in. Oops. But one way or the other, after you plug this all in, we get 1911.17, rounded. And that's typing the whole thing in. Let's say we just go with 1493, just to show the keystrokes again. We would have P1 1493 plus 2.3 times 1 minus P1 1493 divided by 1700, close parenthesis, times 1493. It's not quite right. It's rounded off a little bit, but it's pretty close. So round to the nearest fish, I would be thinking approximately 14, there we go, 1493 fish. And this would be approximately 1911 fish. Now, recursive definitions can be done with your answer button very cleanly. So let me demonstrate. If we start off with our initial 600, and then I'm going to code the recursive definition. Anywhere I see the p sub n minus 1, I'm going to use the answer button. So this would be answer button plus r, which is 2.3, parenthesis, 1 minus answer button, divided by the k, which is 1700, parenthesis, and answer button. If I hit enter, we'll see our first value. That's after 1 year. If I hit enter again, we'll see our second value. That's after 2 years. Now the carrying capacity is 1700. So what's happened with this population? We started at a small amount of fish, and then we approached the carrying capacity, and we shot right through the carrying capacity. We are over the carrying capacity. Too many fish in the pond. They're about to die. Hit enter. Yep, we had a massive die-off. Now we're below the carrying capacity, so we're going to fill up the void. Too many. Die-off. Overkill. Die-off. Over. Die-off. Over. Die-off. This is a very interesting population. Based on the growth rate, it seems to be alternating between not enough fish for the carrying capacity to too many fish. So they're just going back and forth in the cycle of too many, not enough. Too many, not enough. This happens when you have a very large growth rate, which this is, 230% per year. It's almost tripling. Wait, 200, 100 is double, triple. This is over tripling. This is a very fast growth rate. All right, interesting and wonderful that we can code it in. I suggest you practice this, and now you have a chance. Go ahead and pause the video while you work on question number 14. You should get p sub 1 is approximately 565.57, and P2 is approximately 828.80. Watch for the rounding rules. If they don't have any, you can round to what you think is appropriate. Since this is number of deer, I would probably just say there's for sure 565 deer. And here there's 828 deer. I wouldn't necessarily round up because that's not quite a deer yet. It's probably like a pregnant deer running around. So for sure there's 565 deer and 828 deer. Okay, I hope this helps.